my research purpose is quite simple. It's we want to obtain a real gamma ray imaging in the universe. Gamma ray imaging is quite difficult because gamma ray is so quantum. Therefore, it's quite difficult imaging. Therefore, our main purpose is develop really imaging gamma ray device, which are quite useful because it's quite sensitive for gamma ray bursts. In particular, it's so generated at the first phase in the universe. It's our simple motivation, the first motivation. Second is quite useful for the human being, in particular medical imaging. Also, it's because PET is now it's a quite important device for the attacking cancer. But PET observes only one gamma rays. But our device would images all gamma rays from emitting many radioisotopes, which would be possible to develop many kinds of new medicine. I am in Japan. They are quite far from European or USA. It's quite difficult continuous contact with theorist or experienced working in Europe or USA. Therefore, in Japan, only several persons now concentrating this field. Therefore, it's quite now exciting for me. In particular, because I want to carry out the balloon experiment in North Pole. There are Russian people is quite now important for our balloon experiment. Therefore, now in this conference, I have a much discussion with the Russian scientists. It's quite good benefit for me. In the next meeting, I expect also all people have to propose a realistic instrumental proposal. Therefore, we have to constantly get the experimental data for the new device.
What we seek to do together with our colleagues is to make a new instrument, a breakthrough for nuclear astronomy. This is an astronomy of the extremes, the most energetic phenomena, explosions, accelerators, and for observing these phenomena, you need new instruments. I think we have developed, not only in our lab, but in our friend's lab, some quite important new concepts. I have contributed the first gamma ray lens and we have tested it here in a balloon flight in France. And there is some very important telescope concepts developed by our friends in Berkeley. Now, our wish is to put these two things together, a lens, a detector, and build a new space instrumentation. Japanese instrument is an alternative way to the Berkeley instrument to detect. Now, either one, whatever works. Either one. I have a slight preference for the concept of UC Berkeley, but the Japanese way, which was exposed this morning, is extremely interesting also. Usually, a space project, even when it has gone through pre-phases, study phases, as both these concepts have already gone through, it still takes at least 6-7 years. So I would say the horizon of 2020 is reasonable. What is the most violent things which happened since the Big Bang. We know that the processes we encounter here on Earth are ridiculously peaceful in a certain way, fortunately for us, and that out there is unbelievable machines and accelerators. We would like to study these things and learn about the extremes in our universe. So what is this supernova explosion? What is a hypernova? That means an explosion which transforms as much of energy in a fraction of a second as all the stars of our galaxy in 1 year. So that's absolutely outstanding.